Spring.
This is one about gene sequencing.
This what?
Gene sequencing, okay.
Yeah.
Okay. So the numbers in this problem, the drop in cost, that is the actual drop in cost.
Really?
Yeah, so it's dropped by a factor of 1,099.9%.
That was my own fault. Get ready to go on now. You have to tag it, explicit. You know what question are you doing? 6? Yeah, this is
Okay, so,
pretend I'm gonna stitch it all together, but yours is probably better. I'll put it on YouTube.
so the monopolist business is known for 234 pounds per cube, has a total cost per cube. And in the first part of the problem, it says, we also define the profit maximizing Q, basic profit. And it tells you that Q is between 25 and 35.
Yeah, yeah, I think either I am or Tommy, but one of us is dry. Eli's right next to me,
All right.
one of us can, but no problem.
Professor?
Yeah.
What is the QE bracket 25, 35?
Oh, sorry. That means that the problem says that Q is between 25
Oh,
and 35.
it's supposed to be like separate, okay.
Q is an element of that set.
Okay, sorry. That's right.
Okay, so there's a bunch of prices. Okay, your total cost is this going to be 250? Okay, so I'm looking for the profit maximizing Q. And I'm just demonstrating one of these tactics that I suggested, I'm not trying to fill in the whole table. When you do this, for the monopoly, well, for either case, it will be safer for you if you write Q, P, and TR, because then when you compute the total revenue, you're multiplying these two numbers together, rather than TR is like over here, sometimes people actually multiply what the columns together. It's okay. Okay, so now I know that I don't want to go above 29. So to find the answer, I can go down. Okay, so 28 was better than 29. Okay, so if all has gone well, and I haven't made some mistakes doing these calculations, we found that the profit maximizing quantity is 28, the profit maximizing price is 122, and the profits are 3136. Questions? I'm going to write that down. Yeah.
So, and perhaps it's because this won't necessarily be a kind of question on the exam, but like all like these charts that we've done, we're to fill all these in. They've all just been profit maximizing. Are we going to have to do one where the question is, what would this be? Well, like for QB, if you're trying to maximize production instead of profit.
Well, we did one earlier, I think. When the first one of these I did was an output maximization. You should expect to see both. The ones that we're working on now, which are at the end of the exam and have this complication, usually are profit maximizing, because we're usually concerned about trying to get a private sector entity to undertake something.
So in terms of, so if we were to do one that was output maximization, we'd have Q and P and.
You can calculate, if you wanted, you can calculate exactly the same thing, and you just
Right.
go down the table.
Just to see where profit is close to zero and whatever quantity it is.
Yeah.
Okay.
And if you know calculus, you can find the margin or the margin.
No calculus.
Okay. Okay, so, question 7 says, now suppose the development process in question 6 costs $12,000 for year 0 and would succeed in producing the test. However, after the test is developed, it would have to be approved by the FDA. And because it's new, firm believes there's only a 40% chance it would be approved. We're going to assume the FDA evaluation can be done in year 0, so if the firm goes ahead and the FDA approves the profits found in question 6, we begin to arrive in year 1. The firm would be a monopolist for 20 years, after which other people would enter, the price would fall to $10, and the firm's profits would drop to 0. Okay, please calculate the expected net present value using an interest rate of 10%. Okay, so if the firm goes ahead with developing the test, if it doesn't do anything, it gets no payout. So if it does develop the test, it comes to this note where the FDA has to decide whether to approve, and there's a 40% chance. And if it does, then And it gets, that's pretty much cash flow, it gets to be monopolist for 20 years. And if they deny, it gets no profits, but it has to pay the $12,000 cost. So, the present value of this is the usual thing, 3136 for 20 years. The interest rate is 10% there, so be sure not to overlook that. So, this looks like. So the first piece of that is a little under $27,000. So the whole thing is about 14, a little under 15,000. And and if all has gone well, that is a smallish negative. So it's better off for these guys to not develop the test, because it's expensive and they may not get a full approval. Questions?
Where's the 26.7K coming from?
That's this one.
Okay.
It's the actual present value of the profits
Okay.
before subtracting the development cost. All right. Yeah, let me double check that that's the right answer, so we can go over the wrong answer.
And sorry, I have a question.
Uh-huh. Well, we'll go on with this. Do you have a question about this?
Yeah, about this one. It says the firm would be a monopolist for 20 years, after which other firms would enter. Then the price would fall to 10, and the firm's profits would drop to 0. Where are we taking this into account somewhere here, or we don't need to in this problem?
We are. So I'm taking into account in the sense that after year 20, the profits, what I would add in is 0 every year.
Okay.
And so I could put it in for the whole life of the firm. There'd be a product of it because it's all 0, just profit. All right, well, my iPad has chosen this one to offline, so we'll keep our fingers crossed and hope that I didn't commit a math error here and that that's actually the right answer. All right, now let's go on to question 8. Which is about, because you want to do the whole thing, Hector, or just?
Yeah, I think we're going pretty fast on it.
Actually, it's like an hour and a half or fine. No, I'm joking.
Okay, so now consider the consumer surplus if the firm goes ahead and approves the test. So it says, what will the consumer surplus be each year during the monopoly period? So monopoly period, the firm's charging 122, and it's selling 28 tests. So, enjoyed your talk today. Thanks.
He's written so much on that board. It's looking crazy out there.
We only get some better.
Yeah, well, we'll have
shapes
to work
there.
on that. I don't know what's going on there.
Yeah.
I think it actually might be too clean is what happened. They put some kind of chemical on it.
Starting to run.
They did it on all the boards, right? If you
Oh,
figure
yeah.
this out,
Yeah.
all of them through the building have this problem.
Oh. Sorry to disturb you.
Okay, so that's consumer surplus, lot for, the patent period. And then after, we can figure out, from the original demand curve, what, quantity would be. That is 56. So the post monopoly grid. In post monopoly period, the CS is this whole area. So it's $6,000 or so. So let's see what Congress says. What will it produce each year during the monopoly period, each year after the monopoly period, what will be the overall expected present value of the CS? So, So the total present value is the sum of those two streams. Okay, Zach?
And
If it
so,
works.
so that's, okay, that's the benefit from your, they,
Yeah,
have a
so-
CS during the monopoly, and then after that,
Yeah. Monopoly period and monopoly period. And, let's see.
Bless you.
So I gotta say, I'm kicking myself because that's somebody that we're trying to recruit for a job. And the fact that you guys are willing to be here at 5:30 Friday night. I mean, people kill to have students who are willing to do that, but I should have pointed out, these guys don't have to be here now. It'd be a great recruiting device.
Neither do you.
We do it.
I have to be here just because I like doing
We do
this
if we want to
stuff,
pass.
Professor,
Yeah.
just to clarify, on the present value calculation for the post, or for the post-monopoly period, is it supposed to be 21, 22?
Yes, it is, yes.
Oh.
So that would be pretty confusing. So that's 13,349. in. And this is, so,
Where are you getting those ones from?
this one is,
Oh, right.
if I haven't messed up, it's supposed to be that, this is supposed to be.
Okay.
Sorry, Professor, the 9,000 is for, is those 6,000, those are forever?
Yeah. Why are they so small?
Yeah,
You guys wanna take a stab at that?
interest rate is super high.
Interest rate is 10%, right, so I'll double check this in a second, to be sure I didn't mess up, but. So this is, 62.7 divided by 0.1. So this number is smaller than you're used to because of the interest rates, but through two effects. One is that this number is gonna be half the size it would be if that's 0.05. Because when the interest rate is higher, you don't have to put as much money aside to generate the equivalent payments. And then the second reason it's gonna be lower is because this thing is gonna be a lot bigger, so the numerator gets smaller and the denominator gets bigger, and both of them drive, the payout down. And so this top thing, is, 62,720. Yeah, okay, so that is the consumer surplus, but what, the question asks is, what is the expected consumer surplus? And there's only a 40% chance that the test is approved.
Well, I think this is under the assumption that the test is approved.
Uh, Well, this was not as ideally worded a question as one might have liked, because what I intended was that you calculate out the consumer surplus if it's approved, and then you would take one step back and say, okay, now what's the expected consumer surplus before we know whether it's approved? Okay, so it does say what's the expected consumer surplus in the problem. Okay, so
So,
So it's just-
so in this case, the 22,000 is what we expect.
This-
If the price.
This is the consumer surplus if it's approved, but since we don't know, or the intent of the problem, was that what, was to think about what the expected consumer surplus is before we know whether the test is approved, whether the test is approved. So, it's one more step. So it's about $9,000.
So like you, not necessarily, at a more macro level, if you just like listen to the questions. If you're looking at, the expected value, so like your calculation for the expected value of the consumer surplus, which and that means that this is what this is what we expect to happen. But if you kind of have it approved to get this or have it not approved to get this, what does that number actually mean? Like in this case, the $9,069 consumer surplus.
Well, this is what, when the government is thinking about this test, this is what the government would see as the benefit of the firm going ahead with the development project.
Okay.
Okay, so that the firm goes ahead, this is the social component, apart from the profits and the payment for the test, it's just what is the benefit to, consumers, from the test, taking into account that it might fail. So if it works, it's gonna be very valuable in a present value sense, but it might not work, and so this is the average payoff of a lot of activities like this.
I mean, are there other considerations that go into to make the decision based as opposed to just the expected value? Because to a certain extent, if I'm looking at if I look at like that last branch of that tree, and there's a 0.4%, there's a 40% chance it works, and a 60% chance it doesn't. While the expected value is, clearly there's added benefit. 60% of the time, there is no added benefit. It's just money that's being spent to no end.
Mm-hmm.
So in like real life, how that, is there a difference between how we're evaluating these things and how
So,
they're actually evaluated?
so what you guys are grappling with, or being empowered about, is dealing with innovation. Right? These are all about innovation. And innovation always has this characteristic that you don't know before you do it whether or not it's going to work. And in this case, it's most likely not to work. Right? There's 60% chance it's going to fail. But if it does work, it will have a very valuable payoff. And so that's true of lots of development activities. When the numbers here are stylized, but lots of people are facing this problem, thinking about developing these genomic tests, and they don't know. They have the added complication that if they're going to develop it, they don't know that it will work, and if it works, they don't know that the FDA will approve it. And an additional complication is that if the FDA approves it, they don't necessarily know that they'll be able to be monopolists, because what could happen?
Someone else could beat into it.
Right?
Someone else could beat into it.
Some could beat into it, but it also could turn out that they can't actually protect the intellectual property. It could turn out that basically it turns out a piece of basic research and other people could invent this. So I'm not trying to make it scary like I could add lots more uncertainty to your problems, but real innovations always are very uncertain, and the fact that they're uncertain means that if they don't work, you get a bad outcome. Okay, and so, but on the other hand, so this one is, the numbers are small, not in millions or millions of dollars, but for real drug development tests, right, there's more zeros on this. They're very big. And some semesters we look at the value of imperfect information, which we didn't do this semester. When you're looking at any of the old exams and it says some test is imperfect, you don't have any imperfect tests. But a thing which you could easily, not easily, but you could take the tools that we talked about this semester and look at is what the value is of an imperfect genetic test. Like you start testing people and you think they're at risk for some kind of cancer, but sometimes there's false positives, sometimes there's false negatives. Then there's lots of uncertainty including what the FDA will do. Okay, now that my sermon is over, shall I go on to the problem, or is I don't have a follow-up question about why it's worth getting the hang of this. Okay. All right, so the last part of this problem, I think it's the last part, says, so the idea here, set it so far, is that the firm wouldn't want to do this, but the government would like it done. Okay. The government or society or whoever you think is most concerned about benefits that are not. Okay, so now then it says, finally, suppose the government were to establish a $5,000 prize for the first firm to produce an FDA approved test for this disease. Would that change the firm's decision? We're going to assume the firm has no competitors, and the only uncertainty is whether the test would be approved. Okay. So, Okay, so this is gonna have a lot of similarities to the problem that we did earlier. The firm has this similar decision tree to its problem before. The FDA approval thing is the same now. Now, I don't have this written down. Does anybody have handy the payoffs that we had before if the firm proceeds and wins? This is minus 12K, as I remember, right?
Yeah, it's,
Isn't it 50?
Stop it. This is, it's like 26.7.
yeah.
Yeah, 26 fifty.
So, so the only real change is that now if they go ahead and they win, they get this prize, these things are the same as before. But the EV now is 0.4 times. So it's now, you calculate the expected value of that to see if the firm will proceed ahead. And so this is pretty closely related to what we calculated before. Can anybody see what the only difference is? If you didn't want to actually do all the calculations, you just wanted to copy something from the paper.
What would the expected value for the approval, it's just you, $5,000 in there, and then like that.
Yeah, so what we had before was exactly this, but without the 5K. And so this is gonna be exactly what we had before. It's gonna be exactly what we had before, plus a 0.4 times 5K. And so before we had minus 1 point something.
1.32.
Okay, and so, this is gonna be 2K. And so we're gonna be now in the black, by 680 or something.
Yeah. It's gonna be 688,000. Or 0.6, yeah, 680,000.
So these guys are no better off going out. So those are good. Okay, and the very last thing says, would it be efficient for the government to fund the prize? Okay, so, but the government so from the government's point of view, if it goes ahead with this, so it funds the prize. So if it doesn't offer the prize, the firm doesn't develop the test and it gets nothing. If it does develop the prize, or if it offers the prize, actually, I left a step out of here, which is fine if you're doing this, but if in the grand scheme of things, if the government offers the prize, what happens right here is a decision made by the firm on whether they go ahead with the project. Okay, and I'm leaving that up because we just showed they would, but if you did the full decision tree, there's another stage there. So if the firm goes ahead, the government approves the project, then the payoff is going to be minus $5,000 because the government has to pay for the prize. Okay, but what does it get?
I think it's the gain consumer surplus that we calculated, which was expected to be $9,069.
Well, that's the expected, but if we end up down here.
Oh, if it's approved, it's it's $13,349, right? No.
I think it's 22.
Oh, I see. Yeah, 22,672.
So the government is out this payment, but consumer surplus, okay? And then, if the government is concerned about efficiency, not just consumer surplus, what else does it get? What else does it care about?
The price being lower.
Well, the price, like all of the pricing details are built into here.
There's not a loss to the producer, or at least like if
One.
Well-
So SS is equal to
Social.
hmm,
Social surplus.
social surplus.
it's the CS plus the what's it? Is that the
Plus PS,
yeah
plus government revenue.
minus
Yes.
No.
Which is negative, here, we're paying it out. Okay, so if you, so in this problem, is this problem because people have been focused on talking consumer surplus, I can count off if you didn't do the following thing, but in the ideal answer, what else should be in this calculation? Another number. Which you guys have on your pads, because we calculated it earlier. And here it is. Answer that.
Profit?
Sorry?
Profit?
Yes. What is it, what's the total profit?
Profit, 3,136.
3,130, that's the profit per year.
Oh, wait,
That's the 14,700.
Yep, exactly. So if the government, offers the prize, and, and let's see. The last thing we have to take into account, is that the firm actually has to spend some resources doing the research. So this is what happens to consumer surplus if they win, and what happens to profits if they win. This is the development cost. Okay, so taking that into account, we can then calculate the expected value of this, and what you see is that the government will clearly want to get ahead with this. You can calculate it out, but basically, these numbers together are going to be large enough to overcome this point forward.
Just one step further and say, with the question, asking the question of how much will the government pay for the price, that we just,
What's the maximum that would be willing to offer as a
Right.
price? Yeah, you could just put X in here. What's the maximum price? And so So if I take the 40% and I multiply it times the sum of these pieces, and then rewrite it as minus 0.4 times this, plus the thing I just calculated, and then take into account that we pay the $12,000 either way, I get this.
Is it 0.6 times negative 12,000 instead of 12,000 at the next step?
Here it's not because
Oh,
I'm
yeah,
taking
never mind.
into account that there's a 12,000 there as well. So. So, if all has gone well, the maximum prize would be, 73.74.
So therefore, $5,000 is efficient as well.
Yeah, yeah. So $5,000 would be efficient because this, you could already see that without having to calculate this, because you'd see that this is better than this. That this, that the government, counting all the surplus and the expected